Hello, everyone, and welcome to today's Lunchtime Learning webinar. My name is Brendan Woodruff. I'm the co-chair of the Green New York Operations and Engagement Subcommittee, and I'd like to thank you for tuning in today. First, right off the bat, I just want to say that I hope that everybody is staying safe, that they're staying healthy, and that so are your loved ones and the people you care about. It's a tough time right now, but just want to send positive thoughts out to everybody. We're all in this together, and I'm really happy when we can connect in ways like this to feel a little bit more connected to each other while we are staying physically distant. A couple housekeeping things for today's webinar. Everybody is on mute when they enter. If you do have a question, please type it into a chat box and we'll get to that at the end of today's webinar. We will get to the questions. In addition, this is being recorded and a recording of it will be posted on the Green New York website afterwards. So look for that in the next few days. If there's anything you missed or if you want to share it with your colleagues. A couple other things here. Our next webinar is going to be on Tuesday, June 9th at noon once again, and that's on greener travel. You can tell that we made that one, we made that topic a while ago, but there's still some good tips for staycations and stuff like that. In addition, the DEC did a series of Facebook Live posts on their page during Earth Week. There's some fantastic activities for kids, such as birding, backyard birding 101. There's some things on becoming an outdoors woman, and there's one on zero waste tips as well. So if you go to DEC's Facebook page, you can find some of that content. So without further ado, I want to introduce Scott Smith from NYSERDA's Renewable Heating and Cooling team, who's here today to talk to us about renewable heating and cooling. So Scott, take it away.
All right, Brendan, thanks. And thanks a lot for inviting me to join today. Can you hear me okay?
Yep, everything's right. Good.
Making sure the audio is still working. Excellent. Yeah, so I'll start by echoing some of what Brendan said. And these are challenging times that we're in. And I know most or all of us are working remotely. And I also hope that everybody's staying safe and staying sane. I know I've been busier since I've been working remotely than I was when I was in the office, which was a little hard to imagine. But the exciting times, in clean energy generally before the crisis, and hopefully opportunities to keep momentum and see how clean energy and clean energy funding can help with the build back. So as Brendan said, I'm going to talk about clean heating and cooling. That's the department that I'm in at NYSERDA. I've actually been at NYSERDA for 22 years this year. I've done work on a lot of different things. I'm a chemical engineer by background. I've got a master's and bachelor's in chemical engineering. And I've worked on industrial process efficiency. I've worked on large commercial buildings. I've worked on combined heat and power. And my focus now is on decarbonizing buildings. So that's what I'm going to talk to you about today. And, there are a lot of benefits to decarbonizing buildings and to growing the installation of the market penetration of clean heating and cooling. These are some of them. After transportation, heating and cooling buildings is the second largest source of carbon emissions. And if you look, way downfield to where we're going to be when we reach the goals that were established in the Climate Leadership and Community Protection Act in 2050, when we reduced our carbon emissions by 85%, nearly all buildings will be heated and cooled with zero carbon technology. And so the goal, the plan here is the long-term vision is we're going to make the electric grid carbon-free by 2040, and then we're going to electrify transportation and the heating and cooling of buildings, and therefore make those two sources also emissions-free. But in the meantime, while we still have a grid that has fossil fuels on it, there's still carbon benefits in most cases to installing this heat pump technology in buildings. We're also doing other things like increasing the efficiency of air conditioning in most cases, or providing air conditioning where it doesn't exist, which can be a health benefit and certainly a comfort benefit for residents. We're increasing grid utilization in the winter months, which helps to flatten the electric grid curve, which has a financial benefit to the state and its ratepayers. And particularly for people that are on that are using high-cost delivered fuels like fuel oil and propane, there's quite a bit of cost savings that can be had even with the current cost paradigm and technology. Just to sort of reinforce that or show a little detail about the carbon emissions from heating and cooling buildings. And this is heating, cooling, hot water. It's a third of the carbon emissions. You can kind of see, fuel sources and sectors here. And just to mention on this, but this is a slide chart that's actually from a Renewable Heating and Cooling Policy Framework that we published in 2017. Some of the information on the market is a little dated, but it is a good summary of the market, at least a few years ago, and some of the opportunities. So if you're really interested in this topic from a policy perspective, reading that policy framework, which you can find right on our website, is something I'd recommend doing. Just to kind of try and reinforce for residential buildings, and I'm sort of talking to you all. I mean, obviously we're coworkers in New York State, and there's a New York State building and sustainability angle, but also I'm also talking to you all as residents, and in looking at your household energy use, these are average numbers that are put out by the DOE, but pretty consistent with what we see here in New York. And, over 70% of your energy use is for these three things, heating your house, heating your hot water, or heating your water, and cooling your house. And so, it's a bit, if you're looking to reduce your carbon emissions or you're looking to reduce your energy consumption, addressing your heating and cooling is an important step. I mentioned the Climate Leadership and Community Protection Act. I also wanted to mention, a proceeding with the Public Services Commission that sort of establishes a kind of like a near-term target and some funding to try to help us get there. It's called New Efficiency New York, and the final order was issued earlier this year, establishing a budget. It's actually a really big overall budget of about $1 billion. There's $454 million though specifically set aside for heat pump market acceleration by the utilities. So they're going to be providing. We've been running incentive programs the last couple of years for air source and ground source heat pumps, and I'll get into the technology a little bit more in a minute. But the utilities are going to take over that work, or have actually taken over that work as of April 1st, and they're going to be providing incentives in the amount of $450 million over the next 5 years. And NYSERDA is going to be making a companion investment of somewhere around $250 million to support that, to do market development work supporting that. And so, as the states here, as I mentioned, the utilities took over running those programs. So what I thought I'd do, is talk to you a little bit about what the technologies are at a high level, give you kind of a primer on heat pumps. And there may be a varying level of sophistication for all of you, and certainly I'm happy to get into more detail in the questions, and I'm sure that I will get some specific questions. But as an engineer, the thing that gets me kind of excited, that gets me really excited actually about heat pumps, is that they represent what I consider to be sort of an evolution in heating technology. So furnaces and boilers, which is most of us have in our houses, actually create heat, right? So they take a fossil fuel, and they burn it in some sort of igniter, and then that heat is captured by the heating distribution system, whether it's an air-based system or a water-based system, and circulated around the house. And there's a natural thermodynamic limit to the efficiency of that. There's always going to be some loss of energy in the combustion process. Not that there aren't losses in a heat pump system, but that thermodynamic loss of burning the energy is eliminated because the heat pumps don't actually make heat. What they do is they transfer heat from one place to another. So they're transferring heat from your building to the environment during the summer and vice versa during the winter. And I think that's very cool and makes them extremely high efficiency. You couple that with a renewable source of electricity, and it's a great way to reduce our carbon emissions. So, from a technology perspective, you all have a heat pump in your house. The most easily identifiable heat pump in everybody's home is your refrigerator. And your refrigerator is doing something very similar to what a heat pump system would do in your house during the summer. It's taking heat out of the refrigerated space and putting it into your house. So if you've ever put your hand behind the refrigerator, there's a fan back there, and you can feel when the refrigerator is running, you can feel the warm air is coming out of there, and that's essentially what it's doing. A heat pump is essentially the same technology, and it just has a reversing valve so that it can switch which direction the heat is flowing. And we talk about two major categories of heat pumps and really distinguish them based on what the source of the energy is, where you're transferring heat from. And so we talk about ground source heat pumps, which transfer the air between a building and the ground. And I'll talk a little bit more about how in a minute. And then air source heat pumps, which transfer heat between a building and the outside air. And this is something that so sort of the people that are in heat pumps get questions about a lot from people who aren't as familiar with them. Is there really enough heat in 0-degree air to heat a house? And the answer is yes. There's a lot of heat in any medium, and it's just a matter of efficiently compressing it and transferring it into the building. And air source heat pumps can work down to even negative temperatures. There's some that are rated down to even below minus 13 degrees. So again, two basic types of heat pumps. On the left-hand side, air source heat pumps. On the right-hand side, ground source heat pumps. For air source heat pumps, two main types for homes that are used for space heating. Ductless mini splits, which actually represent somewhere in the neighborhood of 75% of the state's air source heat pump sales, or heat pump sales really. And then centrally ducted systems. So a centrally ducted system would drop in where your furnace goes in your house. Sort of a one-for-one replacement with that. The ductless mini splits are nice and flexible in that they can serve a single room, serve a zone in the house, and they're efficient in that they eliminate the losses that a ducted system typically suffers from. There are also heat pump hot water heaters in the bottom left-hand corner. And I have variable refrigerant flow systems kind of in the middle here because that technology is used for big buildings, and you circulate the refrigerant around the building instead of circulating water or air around the building. And they're in the middle because they can be connected to either an air heat exchanger or a ground heat exchanger. And then on the right-hand side for ground source heat pumps, we typically distinguish those by the type of loop, the type of heat exchanger. And I'll talk about the importance of that more in a minute. But there are closed loop systems, which are on the top, those four types. There's a thing where you can bury refrigerant piping directly in the ground called direct exchange, and then there are open loop systems. All right, so I'm going to get into some more detail now on ground source heat pumps and kind of how they work and why they're important. As I mentioned, ground source heat pumps transfer heat from the ground to the building and vice versa. And The ground is actually relatively undisturbed. The ground is a relatively stable temperature. So, 15, 20 feet below the ground in most areas of New York State, it's about 50 to 55 degrees in the ground. And so that makes ground source heat pumps actually the most efficient type of heating and cooling system that you can get. The exchange with the ground, as I mentioned a slide or two before, is done through a heat exchanger, and there are a number of different types of them. I showed them on the screen a minute ago, and I'll talk a little bit more about them in a minute. But they're permanently installed systems, usually a system of pipes that are installed in the ground that exchange heat that facilitate the exchange of heat between the building and the ground. Because of the relatively constant temperature and the relatively moderate temperature that the ground source heat pump system can use to exchange with the environment, they're really efficient. And so for every unit of energy that you put in to the heat pump system, you're getting theoretically four to six thermal units of energy out. And in the field, actually, this is hypothetical. We actually have field pilot measurements that are going on that have shown that it's in the field with all the additional losses in the field, it's still 350 to 400% efficient. Most of the systems in New York State and most of the systems that are installed right now are closed loop systems. They can be a little bit more costly, but they are definitely the most reliable and most stable, and we think best for the environment. There are 4 different types. I'm not going to read all the content on this slide. I'm sure you'll have access to the slides later. Horizontal systems are where you'd dig a shallow trench and bury pipe there, and I'll show a picture, or maybe I don't even have a picture in the slide deck, but you can kind of picture how that would work. Vertical heat exchangers are holes drilled in the ground, and then you put pipe down to the bottom of the hole, cement it up to the top, and you can also put the tubing in like a body of water, like a pond. So that's a quick primer on ground source heat pumps. Air source heat pumps are really similar, and although they exchange the heat with the outside air, and as you can probably kind of imagine from a physics or an engineering perspective or thermodynamic perspective, it's harder to it takes more energy to either discharge air to 90 degrees in the cooling season or to try to extract air from 0 degrees in the heating season. So they're still more efficient than furnaces because they don't actually suffer from that combustion loss. But they are less efficient, slightly less efficient than ground source heat pump systems in the neighborhood of 250 to 300%. So the 2 main types I talked about on the before, ductless mini splits you can see on the left, centrally ducted systems on the right. The centrally ducted system, as you can probably see, looks a lot like your central air conditioning system, and it basically is. It's that with a reversing valve. And that the actual air source heat pump would go right where your furnace does, and it probably looks a lot like your furnace does if you have one. And then the mini splits are a good fit for a lot of buildings, especially those that might have existing hot water systems. And as I mentioned before, they don't suffer from the duct losses that the ducted systems do. I kind of mentioned a lot of this already and don't want to go through it in a whole lot of detail, but these are some of the considerations that you might want to go through thinking about which type of system you want for your house. And as I mentioned, the ductless mini splits represent about 75% of the sales currently in New York, and those can be installed as single zone systems where you have one indoor unit, which is this thing on the top left, and one outdoor unit, which is the thing on the bottom left, or you can set it up where you have one outdoor unit connected to multiple indoor units. So I'm going to talk quickly about variable refrigerant flow technology, which, essentially, in this, as I mentioned before, this is typically a better fit for larger buildings, and it's zoned a lot like a rooftop unit system might be. So, and I guess I'll just pull that up right now. So I'll just show this really quick, and then I'll come back to it. So each of these, each of these units that you can kind of see hanging from the ceiling would be analogous to what a rooftop unit would be. So it's kind of zoned like that. And then between the zones, you have, instead of distributing the heat with air or water, you're actually distributing the heat with the actual refrigerant. And there's some inherent efficiencies in that. Generally, so that refrigerant system that I just mentioned be connected to outdoor units like this, on the top of the building, or could be connected to a ground heat exchanger, as I mentioned previously. One of the potential benefits to VRF systems is that they can do simultaneous heating and cooling and heat recovery. So the refrigerant goes back to this thing that's labeled branch controller there, and sort of exchange the different refrigerant lines exchange heat with each other before it's sent to the outdoor unit, which increases the efficiency relative to say a ductless mini split. One of the issues here is there's a lot of refrigerant piping, and that makes it a little costly to install. And there are some leak risks, or more leak risks than there would be in a package system. But as long as the piping is installed well by a knowledgeable contractor, there shouldn't be any leaks in the system. So that's an overview of the technology, and it took about 20 minutes, but felt quick. So hopefully that was good enough, and was very much looking forward to answering your questions. I'm just going to take a few more minutes to talk about one of the things that we're sort of doing to help grow the market. We're funding these clean heating and cooling community campaigns around the state, and they're essentially local community-based organizations that are helping to primarily, educate consumers about the availability of heat pumps, also talk to residents about the importance of reducing their heating load and tightening up their building envelopes, and then facilitating relationships between those customers and installers that these campaigns have selected, to try to facilitate a high quality, lower cost installation. We actually and to reduce those costs by essentially aggregating, providing a pipeline of customers for contractors, and reducing the soft costs or the customer acquisition costs. We also are providing them with some funding for local workforce development, because growing this workforce is an extremely important part of our task for the next 5+ years. And we're also doing some pilots to try to figure out how to better engage low to moderate income households in New York. So we currently have 15 communities that are active in the state right now, and we're adding another 12 by the end of this summer, so we'll have almost 30. You can see where they are right now. Unfortunately, we don't have contracts in place with the new ones, so I can't show you those yet, but we will be able to. A map like this is up on our website right now, and we'll add to it once we have the new contracts in place. And I don't know for sure, but I'm assuming that many of you on the phone are in the Capital District, and so I wanted to point out that we have a Heat Smart Capital District campaign run by the Capital District Regional Planning Commission, and I wanted to talk to you a little bit about that campaign. And what would be an awesome outcome for me from this meeting is if many of you enrolled in that campaign. There's no commitment to enrolling. It's just sort of a request to learn more, and there's some events that you'll get invited to, and you can meet their installers and think about whether you want to reduce your carbon emissions by either improving your building envelope or installing a heat pump, or maybe both. So Heat Smart Capital Region, as I mentioned, run by the Capital District Regional Planning Commission. They're they're doing these technologies, so energy efficiency, ground source heat pumps, air source heat pumps, and heat pump hot water heaters, and doing a lot of things that I talked about. They're targeting homes and small businesses, but not limited to that. And it's a great group of people that can help work with you, that can help you, decide what's the right fit for your home. And particularly if you have an aging heating system, or if you're using a delivered fuel like fuel oil or propane, this is definitely something that you should get involved in. So they put out, like most of these campaigns do, they put out an RFP and chose installer partners, and these are their installer partners. And so what will happen if you get involved in the campaign is they'll work the Heat Smart Capital Region staff will kind of help you figure out what your needs are and what you're interested in pursuing, and then they'll facilitate a connection with one or more of these installer partners to do right now some remote auditing, figure out what you have, talk to you about that, and then eventually, if you're interested in exploring it further, facilitate a proposal, and then be there with you throughout the process to help answer any questions that you have, make it super easy. Wanted to quickly also mention for those that might be interested or even know someone who is interested in getting into this workforce, there's a partnership between Heat Smart Capital Region and these contractors and Hudson Valley Community College and others to do workforce development. We really need to bring a lot of people into this space to do this work. A lot of the HVAC contractors, heating, ventilation, and air conditioning contractors in the state are retiring. And not a lot of young people have been entering the trades, and the ones that don't really know heat pumps. And so we've got a lot of things that we're doing, including those that are shown on this screen right now, to try to bring people into that workforce. So, question is, what do you do next? You contact Heat Smart Capital Region. Probably go to their website. There's an enrollment form right there that you can fill out. Or if you'd prefer to talk to somebody, Todd Verbozzi is the campaign director, and this is his phone. Apologize for the dog barking in the background. And that is my presentation, Brendan.
Awesome. Can you hear me?
I can.
Good. Just having some audio issues there, but straightened out, which is good. That was fantastic. Thanks a lot, Scott. I know this it really kind of demystified the technology quite a bit. I know I've had some questions about it myself, and that was a really thorough way of going through all the lines that are out there. So, got a couple questions here. The first, I'll start with a comment. My parents actually installed a ground source heat pump about 8 to 10 years ago at their house, and they've had really good luck with it. It's worked out well for them. They unfortunately had to install the ductwork as well, so it turned into quite a bit of project. But one thing they have noticed is that on super cold nights, 10, 15 below, they still have to use their old pellet stove as kind of a backup. Do you know if the technology has kind of progressed on how it works in super cold weather like in the North Country?
Well, so certainly the air source heat pump technology has progressed and can work down to those temperatures where, maybe 10 years ago it couldn't. Ground source heat pump technology has improved too. The efficiency of the heat pumps have gone up. There's more sophisticated variable speed technology which improves performance. Honestly, that issue, Brendan, or the way that your grandparents' system works during those cold temperatures is largely a design issue, likely, and it could have been designed from the start to maybe do better, not need any kind of supplement or backup during those really, really cold days. Often a designer compromises though, because those days don't really happen all that often, and so you might actually talk to a customer and say, hey, would you prefer to maybe use your pellet stove on those super, super cold days? And if so, I can install a slightly cheaper system for you. But I mean, the bottom line is I think a ground source heat pump system can be designed to meet loads at those temperatures, no problem. It's just a matter of design and installing enough capacity.
That's awesome. Yeah, and they had some issues with having a high bedrock as well. So probably that's one of the issues with that is not being able to fully get to where they wanted to. So next question.
Maybe, but Brendan, if I could just chime in on that really quick.
Oh, yeah.
That's a common misconception that people a lot of times have. It's bedrock and being close to it, having not a lot of soil between the surface and the bedrock is actually generally a good thing. It's easiest to drill under those conditions for the most part, and it reduces the amount of protective casing you need. So, bedrock is not necessarily a bad thing. It's usually actually a good thing for ground source heat pump systems. Just to
that's good to know.
Address that.
Yeah, no, I'm glad we could use that as kind of an example. So the next question here, have you heard of an odor issue called dirty sock syndrome in New York or anything involving heat pumps and odors?
Interesting. I haven't. I certainly have not. I apologize. I have not heard of dirty sock syndrome. And I've heard some issues with noise. Typically, generally, I think these systems are really quiet, and often that's a benefit. People talk about that. There have been times when, due to location, of the heat pumps, there have been people who've said they had a noise issue to address. Odors hasn't come up. I'd be interested in learning more, and whoever it was that brought that up, if you want to maybe, shoot me an email. I guess I realized I didn't put my contact information in the slides anywhere. It's pretty easy, though. It's scott.smith@nycerta.ny.gov. And I'd love to learn more. But no, odor issues aren't a common thing that comes up related to heat pumps. And because there's no combustion, there's no carbon monoxide, there's no smell related to that, there's no oil storage. So typically I think they're seen, or, typically they're going to reduce odors, if anything. But I'm interested in learning more about what that might be, the dirty sock syndrome.
Yep. The next question here, what's the average bury depth for a horizontal ground source system? And does it need to intersect the water table?
So it needs to be installed below the frost line, is the most important thing. And that's, if I remember right, that's at least 7 feet deep. I think the average depth is probably, between 8 and 12 feet. It doesn't have to intersect the water table, but that can benefit the heat exchange. So if you have water table at the depth that you can trench to, it might change the size of the amount of piping that you need, because you'll get better heat transfer in wet soil than you will in dry soil.
So I've had a couple questions come in about where folks can get information on contractors and the programs outside of the capital region. Is there a website that NYSERDA has where people can go to learn about their local campaigns?
Yeah, if you're looking for another Heat Smart campaign, that map that I showed during my presentation is up on our website. And you go to nycerta.ny.gov, find a program, Clean Heating and Cooling Communities. And I could probably facilitate getting maybe a link to Brendan that he can send out. It's pretty easy to find, though. And then there's a map of them, and if you hover over the campaign, it'll show you who's running the campaign and the contact information for the campaign. And then we actually still have, even though we're not running the program anymore, we still have our participating contractor lists. If you're looking, the first part of that answer was about the campaigns. If you're generally looking for installers, the participating installer lists from our program are still up on our website, and the utilities are building theirs, so there will be installer lists up on the utility websites eventually too.
Awesome. And next question here. What is the difference in price between the ground source and the air source systems?
Yeah, so that's a really good question. A lot of it depends on whether you're sizing it for your whole house or, which is usually the case, almost always the case for ground source heat pumps. It's a little less often the case for air source heat pumps, depending on the customer's needs. Typically, we're talking about, $15,000 maybe for a typical home if you're going to do the whole house with the whole home with air source heat pumps, and maybe between $35,000 and $40,000 in most of the state for a ground source heat pump system. Both of those numbers are before the incentives. So there's a utility incentive for both air source and ground source heat pumps that kind of helps to bring the costs down quite a bit. And there's also a federal tax credit specifically for ground source heat pumps of this year 26%, which further brings down the cost. So you can get a ground source system after tax credits and incentives installed for in the neighborhood of $20,000 to $25,000. And a lot of the contractors are offering no money down financing for the systems. And then after the incentives, the air source heat pump system, it may be in the range of $8,000 to $10,000. So both are still more expensive than a furnace or a boiler. But if you have to replace your furnace or boiler anyway sometime soon, then there's pretty significant cost savings available, especially if you use a delivered fuel like fuel oil or propane. And if you happen to heat with electricity, it's pretty much a no-brainer to go to heat pumps because you're going to quadruple your efficiency.
Mm-hmm. And with that, do you have any kind of, or is NYSERDA run any numbers on kind of total cost of ownership of various heating systems? Like fuel oil versus gas versus heat pumps.
Yeah, so there's some information like that in our renewable heating and cooling policy framework, and we need to do more. That's something that we need to do more of. We're doing a series of pilots around the state that are wrapping up now. Actually, we've been working on it for a couple of years. So we did 40 air source heat pump systems in the Hudson Valley, 20 in like the northern Hudson Valley, and then 20 in Brooklyn and Queens. We're doing 30 or so on Long Island. 30 or so ground source heat pump systems on Long Island, and that data is going to be on Open New York, and we're going to publish reports on it soon, which will help answer some of those questions and questions people have on performance. And we're sort of regularly on the lookout for and trying to develop case studies that'll help also answer that question.
And can you speak a little bit more about incentives that are available to low and moderate income communities for this technology?
Sure. So the low to moderate income households, which are, as people probably know, about half of our households in the state, are obviously eligible for the utility incentives. We generally know that that's not going to be enough. That's not going to be those incentives are generally not going to be enough to bring these technologies within reach of those customers. So we actually have a specific pot of money set aside to figure out how to solve that problem. We're going to be spending about $30 million over the next few years, testing out concepts to make these technologies more affordable for LMI households through different maybe ownership models, like a leasing model or a pay-as-you-go kind of model. We're also going to be in the near term. Very likely, we're still waiting for approvals of a lot of this, official approval of a lot of this work, but we're likely going to try to add to the utility incentives for some of those customers in the near term.
Mm-hmm. So we've had a number of specific cases come in. We talked a little bit about my parents' example there. So I had another one here I'll just throw at you because I think this gets kind of into what we were talking about since every house is different in terms of the heating and cooling systems. So do you have any recommendations for a home that has central AC? So it has the ducts that are mounted to the ceiling and an oil furnace with baseboard water heat. Do air source heat pumps work well with the ducts being up on high, or is there a way to tie a heat pump into baseboard water?
Yeah, so it's a great question. We actually did a pilot of looking at 5 houses in sort of like the southern tier, there are heat pumps that are available that will make hot water for heating, but there aren't very many of them, and so it's sort of an emerging, not yet completely commercially available technology in the U.S. And the heat pumps produce low temperature hot water, so you have to make some adjustments in the baseboard radiation systems, or maybe in some cases install some additional supplementary air based heating. I think and so both air source and ground source can interface with a hot water system, but there's more work that needs to be done on the technology there. You can have a contractor come in, and often your cooling only ducts will be of sufficient capacity to do the heating. That's not out of the question, but you need to have somebody take a look at that. Another option would be to just install a ductless a system where you'd sort of abandon the ducts in place and the oil furnace, or you might probably keep the oil furnace for backup on the coldest days. And then install a ductless system with maybe 3 or 4 outdoor units serving the house, depending on how big it is.
Mm-hmm. So this is kind of a general question about NYSERDA grant programs, but have there been any changes with the current pandemic and economic situation to any NYSERDA programs?
No, sorry, I'm not sure if I understand the question. We are making some changes and already have made some changes to programs as our response to the pandemic, to try to, make things easier for contractors and customers, changing or accelerating payment schedules. We've, for example, increased the cost sharing for our internship and on-the-job training programs. So that was the crux of the question. We have made some of those changes, and more are coming. To try to help the industry, and consumers kind of stay on the path to clean energy and capitalize on whatever opportunities there are more easily. I saw a question pop up in the chat, although they're going by fast enough for me not to read them all. I thought someone was maybe asking whether there are budget implications as a result of this that have arisen yet, and the answer is no. None that have arisen yet. I mean, it's always sort of a possibility when we're in really tough times like this, but so far, the funding, generally, if we've committed funding to a specific contractor, if NYSERDA has committed funding to a specific contractor, project, or program, we'll follow through on those commitments even if things do change. But right now, I'm not aware of any changes to clean energy funding as a result of the pandemic.
Mm-hmm. Are there any radon issues or things to consider with the ground source heat pumps?
So that's a good question. I don't think there's anything. I mean, these heating systems, the heat pumps will often be located in your basement where your furnace is, and so radon levels in your basement are still something that you need to be concerned about. But I don't see any real difference there. I don't think that the heat exchanger has to be a certain distance from your house and other structures and surfaces and services like the gas line and the sewer line, and so I don't see having a heat exchanger. I've never heard of, let me just put it that way, I've never heard of an issue with any increased radon danger as a result of having a ground source heat pump heat exchanger. Mm-hmm. You have to make sure that the connections into your home or into your basement are all properly installed, just like you would with a gas line or a fuel oil line.
Mm-hmm. So most of this has been focused on residential, but we did get a question here about, has NYSERDA done any work with community shared heat pump systems for suburban or urban areas? I think the questioner is probably thinking about something like the city of Boise in Idaho that has geothermal system for their entire downtown. So are there any plans at NYSERDA looking at kind of shared systems in urban areas?
Yeah, that's a great question, and actually we see that as an important part of the path forward here. And so one of the things, I mentioned this $250 million-ish market development effort that we're going to be leading for the next 5 years alongside the utilities and their incentives. And there's a focused, there's a planned investment on clean thermal district systems as part of that, where we're going to fund some initial scoping studies for those systems, help pay for some detailed design, and then probably even help with the construction costs for some of them. And it's exactly the kind of thing that I think you were just mentioning, Brendan. A downtown area, section of waterfront could be some kind of a campus, or like a big multi-use multi-use development, those kinds of things.
Mm-hmm. So another question here came in regarding the refrigerants that are used in these. Can you talk a little bit to those, and do you know if there's ones coming on the market that have a lower global warming potential than traditional ones?
Yeah, so there's a lot of work being done on global warming, low global warming refrigerants. Some by us. So NYSERDA actually has a couple of research projects looking at how we can improve, how we can essentially. One of the issues with the low global warming refrigerants right now is that the technology, having those refrigerants reduce the performance of the technology pretty significantly. So we've got a couple of research projects that are looking at ways to to overcome that by fundamentally changing the refrigerant the refrigeration technology used in these systems. And there's a lot of work being done elsewhere looking at alternatives. I mentioned previously that there are these heat pumps that create hot water, and several of those technologies actually use carbon dioxide as a refrigerant, which is much lower global warming potential than the refrigerants that are used right now. The standard refrigerant used in these systems right now is the same refrigerant that's in your car or your refrigerator at home, R410A. There's no, and so to sort of sum it up quickly, there's no currently identified universal replacement that's a low global warming potential refrigerant yet, but there's a lot of work underway, including using, I think, butane and other types of sort of fossil fuel, low flammable refrigerants. So I think eventually there will be a switch from where we're at right now in 410A to something that's lower global warming potential. Our current focus on that is to make sure that we have high quality installations, and that only people who are qualified to handle refrigerants and to properly pipe it and test it and make sure that it's not leaking are allowed to install the systems.
Mm-hmm. So I just want to remind people, if you do have any final questions, please type them into the chat box now. We've got a couple minutes here still. So if you do have any further questions, please type them into the chat box. One last one here for you, unless we get any other ones. Are there any issues with disposal of these? I know we're right at the beginning of the technological kind of adoption curve here, but we're always trying to think of kind of end-of-life care for new products as they come out. So are there any special considerations with that?
Well, so I mean, I think like anything that has refrigerant, it's going to be important that refrigerant, when the system is decommissioned, is recaptured, and because of its value, I think that generally there's some pretty good work being done on refrigerant reclamation now, but I think that is something that we should all focus on moving forward, especially looking out to the future years when there's going to be a vastly larger number of these systems installed. There's going to have to be we're going to have to make sure that that's done well.
Mm-hmm. And just checking here for any final questions. Can you clarify a little bit about what it means when you're signing up or enrolling for the Heat Smart campaigns?
Yeah, so essentially what you do is provide them with your information and let them know, like, enroll in the campaign. And when you do, you're basically raising your hand to say you're interested in learning more. And so, Heat Smart Capital Region staff will contact you and, ask you about your current situation, what your interests are, what your heating system is, whether you've had energy efficiency work done in your house, provide you with resources, necessary to kind of help you learn more about the options that are available. And then, if you become interested enough to talk to an installer, you'll have I had up on the slide recently, they're installer partners, and so you'll have ready access to one of those, and then help along the way as you move down the decision-making process.
Mm-hmm. And one final question here. So can a heat pump be installed alongside a mid-life furnace to extend the furnace's life and prevent the need to install another furnace in the future?
I think generally yes. You can put in an air source heat pump system that significantly reduces the runtime of your furnace, and that should increase its useful life. I mean, it's not going to extend it indefinitely. There'll still be some point in time when it stops working. But yeah, if the way a typical air source heat pump system is going to get installed is that it's meeting 80-90% of the heating load, and then you'll have the backup fossil fuel system that runs on the coldest days, and because it's only running a lot less frequently, that should extend its life.
Mm-hmm. And one final question here, and this is kind of a little bit off topic, is regarding community choice aggregation and NYSERDA's role with, I know there's been some campaigns in the Capital District and other areas. I'm not sure if you're able to speak to kind of what NYSERDA has been doing in that realm as well.
Yeah, well, I'm not directly working on that, but we have been providing some funding and some assistance to areas that are interested in doing a customer choice aggregation program. And actually, it's a great way to get. So it's a way to make your community's electricity renewable, even as we're building out the additional renewable capacity. And it's a great fit. We have a lot of our Heat Smart campaigns are also doing community choice aggregation as a way to get their residents heating and cooling, fossil fuel free, sooner rather than later. And I don't know specifically what we're doing, with respect to the capital region, but I'm hoping that we're supporting it. And if whoever's asking that question wants to shoot me a note, I can find out in more detail from my colleagues.
Yeah. So with that, any final thoughts for everybody?
Well, I certainly wanted to thank everybody for their time. Thanks for the great questions. Thanks for the opportunity to speak with you. I wanted to reinforce. I mean, we talked about the refrigerant issue a little bit. It is a really important one, and something that we have to do more work on as we move forward, both in making sure that the system's installed properly, that we capture it at the end of useful life, and that we ultimately transition to low global warming refrigerants. So I just want to make sure that I emphasize how important that is to us and to the state. Really appreciate the opportunity to talk to you more about these technologies that I live and breathe every day, and happy to answer any questions that come up afterwards. I hope many of you will enroll in Heat Smart Capital Region and work with Todd and his team to learn more. Thanks a lot for having me. Really appreciate it.
Yeah. Thanks a lot, Scott. This was absolutely fantastic. And as I mentioned before, I think it was a great way to kind of demystify something that people have heard about but might not understand that great. So with that, again, thank you everybody for attending. Our next webinar is going to be Tuesday, June 9th at noon. And again, that is going to be on greener travel. You can register for that right on the Green New York website. And we will have a recording of today's webinar up on the Green New York website in a few days. So thanks a lot, everybody. Stay safe, stay healthy, and stay in touch. Bye.
Thank you.